Hello students, today we will study about factorize. This is the topic of standard 9 chapter number 2 polynomials. So, whenever there are three terms, right? See, one first example that we have taken is 12x square minus 7x plus 1. We want to factorize this polynomial. This type of sum you have already studied in standard 8. We used a method that is called the splitting the middle term method to factorize this kind of polynomial. And what we used to do is, first of all, consider this constant, it is 1. Consider the coefficient of x square, that is 12. Multiply both. 12 ones are 12. We get the total number is equals to 12. Now, factorize this 12 such that the addition of both the factors becomes 7. So there are many factors of 12, like 6 2s are 12, but the addition of 6 plus 2 is not 7. 12 ones are 12 is also a factor, so 12 and 1. But addition of 12 and 1 is also not equal to 7. One another factors are there, 4 3s are 12. And yes, the addition of 4 and 3 is 7. So we have to divide or split this middle term 7x as 4x and 3x. Right? So we can rewrite this 7x as, see, this 12x square as it is, this 7x now we can write down is a 4x minus 3x, and this plus 1 remains as it is. One thing you have to notice is that if there is a minus sign, we have to take both as a minus sign. In short, the simplification of both these terms should become equal to minus 7x. Right? We cannot take the different sign here. We have to take same sign so that the addition of both these terms becomes 7x. Now we have 4 terms. So now we can make the pair of 2 terms, first 2 terms and second 2 terms. Now take the common from these first 2 terms. What we can take common from the constant? We can take 4 as a common, and from variable we can take x as a common. So 4x is the common. What will remain here if we take 4 as a common? 4 3s are 12, so 3 will remain, and x raised to power 2, 1 power we have taken as a common, so only 1 power will remain. So 3x will remain here as it is. Now from here 4x, all we take as a common, so 1 will remain that. So this bracket is over. Now we have to take common from this 2 term. There is nothing common between 3x and 1, but yes, 1 is a common factor of all the variables and constant. So we can take 1 as a common. Why we take minus 1 as a common? Because we need to make this type of same bracket here. If we take plus 1 as a common, we will get here minus 3x plus 1. So these two brackets could not be same. So here, that is why we take the minus 1 as a common. So now this 3x become plus and this 1 become minus. Now both these brackets are common. So how many terms are there remain now? First of all, there are 3 terms. Now there will become 4 terms. Now there are only 2 terms. So now from this first term and second term, 3x minus 1 is common. So take this bracket as a common from both the term. This is the 3x minus 1 as a common. Now what will remain? 4x minus 1. Put it in another bracket. So now both these terms are in multiplication. Yes, that is why this is the factorization of this 12x square minus 7x plus 1. Right? So we can write down this 12x square minus 7x plus 1 is equals to 3x minus 1 is the first factor, 4x minus 1 as the second factor. Let us take one more example. 6x square plus 5x minus 6. Again, take this constant 6. Coefficient of x square is also 6. 6 is 36. Now we have to factorize this 36 such that the subtraction of 36 becomes plus 5. So there are also many factors of 36, but we have to consider that factors only, that the subtraction of both the factors becomes 5. So now we can choose 4, 9 4s are 36, and the subtraction of 9 and 4, 9 minus 4 is equals to 5. So we can write down this 5x as 9x minus 4x. Okay? So rewriting this 5x, see 6x square as it is, 9x minus 4x minus 6. In short, the simplification of both this term must be equal to this, and it will okay. So now again make the pair, take the common from both this. We will get from the constant 3 is the common, from the variable x is the common. What will remain here? 2x, and what will remain here? 3. In the same way, from both these two terms, minus 2 we can take as a common. So what will remain in this? 2x, and here sign will become plus and plus 3 will remain. Why minus sign becomes plus? Because minus sign we take as a common. So this sign becomes plus. Notice that both the brackets are equal. Again take this 2x plus 3 from both the term as a common. 2x plus 3 is a common. What will remain? 3x and minus 2. Put it in another bracket. So this will the factorization of this given polynomial. We can write down 6x square plus 5x minus 6 is equals to 2x plus 3 and 3x minus 2. Both are the factors of this given polynomial. So in this way, whenever there are three terms or whenever there is a quadratic type of polynomial, we can factorize it by the splitting the middle term method. Okay? Okay, so let us understand one more example, that is x cube plus 13x square plus 32x plus 20. Give it the name as a polynomial of x, p of x. So here this is a quadratic type of polynomial. Previously we have studied this is a quadratic cubic type polynomial. Previously we have studied about the quadratic type of polynomial. So how to factorize this? See, already 4 terms are there. So by making a pair and by taking some constant and variable as a common, if we make the pair, if we make the two brackets equal, then we can easily factorize this polynomial. But no such things we can do here, because if we take x square as a common here, what will remain in the bracket? X plus 13, and here we can take 2 or 4 as a common, then here it will 8x, and here what will remain? 5. So both the brackets are not equal. Again, by rearranging the term, we cannot do that type of factorization by taking the common. Then what we can do, what we have to do to factorize this kind of polynomial? So there is a method that is called the trial and error method. Now you may have a question that what is that method? For that method, we have to first of all take one of the factor, or we have to suppose one factor. Like suppose that x plus 1 is a factor of this polynomial. It is not necessary that we have to suppose x plus 1 as a factor. We can suppose x minus 1 as a factor. Let us take x minus 1 as a factor. So what will happen if x minus 1 is a factor? We know that according to the factor theorem, if x minus 1 is a factor of this polynomial, then by dividing x minus 1, the remainder becomes 0. But here, when we put the value of x is equals to 1 in this polynomial, we cannot get this all as a 0, because all these terms are positive. So according to that, x minus 1 cannot be the 0 of this polynomial. So now what we can do, let's suppose x plus 1 is a factor. So if x plus 1 is a factor, then the value of x we get is equals to minus 1. Now according to the remainder theorem, if we want to find the remainder, put this value of x in this polynomial, and if it will become 0, we can say that x plus 1 is a factor of this given polynomial. So by doing this, put the value of minus 1 in this polynomial, we get the p of minus 1, because it is a p of x. Instead of x, now we have to put minus 1. So the p of 1 is equals to, what will happen? Cube of minus 1 is minus 1. Cube of minus 1 square is plus 1. So plus 1 into 13 is plus 13. Minus 1 into 32, minus 32. This 20 will remain as it is. Plus 20 plus 30 plus 33, minus 32 minus 1 minus 33. minus 33 plus 33 is equals to 0. So what will happen? This remainder becomes 0. According to the factor theorem, if remainder becomes 0, we can say that x plus 1 is a factor of this given polynomial. So what we do? We suppose one factor. First of all, we suppose x minus 1 is a factor. That is our trial. At that time, we did not get the remainder as 0. So there become an error. There it gives us error. Now do the second trial. Take x plus 1 is a factor. By doing this, we get the remainder 0. So now we can decide that x plus 1 is a factor of this polynomial. So in this trial, we get the success. So stop this process now. That is why it is called a trial and error method. What will happen if x plus 1 is also not become the factor? We have to take x minus 2 as a factor. New trial. If we get the error, we have to take x plus 2 as a factor. So in this way, one of the factor we get such that the remainder becomes 0. Okay. Now what is the next step? We get the one factor. Now we know that as the remainder becomes 0, we have to divide this given polynomial with that factor. So here we have to use the division method. So this is the given polynomial x cube plus 13x square plus 32x plus 20, and this is the factor polynomial. We know that by dividing these, we definitely get the remainder as 0. So let's divide it. What will the first term as a quotient? We get the first term as a quotient as x square. Now you know that how to get this quotient, right? By dividing this first term with this first term. So x square is our first term. So x square into x, that is x cube. X square plus 1, that is x square. Now change the sign. What will happen? This x cube and x cube will cancel out each other. 13x square minus x square, that is equals to 12x square. These two terms remains as it is. Now to get the second quotient, divide this 12x square with x, we get the 12x. 12x into x, that is 12x square. 12x into plus 1, that is 12x. Again change the sign, both will become minus. Plus 12x square minus 12x square will cancel out each other. Plus 32x minus 12x, that is equals to plus 20x, and this 20 will remain as it is. To get the third quotient, divide the 20x with x, we get the 20. 20 into x is 20x, 20 into 1 is 20. Change the sign, this 20x and 20x will cancel out each other. This 20 plus and this 20 minus is also cancel out each other. What will become? Remainder becomes 0, as I have said earlier. So x plus 1 is a factor of this polynomial. Now again, we can write down this p of x polynomial as the product of this polynomial and this quotient polynomial. Remember the division algorithm. Dividend polynomial is equals to divisor polynomial into quotient polynomial plus remainder polynomial. But here remainder is 0. So by adding 0, we will get only this term. So p of x is now the factor of two terms. First is x plus 1, that is linear polynomial. Second factor is x square plus 12x plus 20, that is the quadratic polynomial. But we now can factorize this quadratic polynomial by splitting the middle term method. So this x plus 1 remain as it is. What is the coefficient of x square is 1. What is the constant? It's 20. 21 is the 20. Factorize the 20 such that the addition of both the factors become 12. So we can factorize this 20 as 10 to the 12, because 10 plus 2 is 12. So this x plus 1 remain as it is. What will happen? X square plus 10x plus 2x plus 20. Now there are 4 terms. Take the common from the first two. We get x as a common. What will happen? Remain here x, and here 10. Bracket is over. Take 2 as a common. What will remain here? X plus 10. Notice that both the brackets are equal. Take x plus 10 as a common. What will happen? This x plus 1 remains as it is. This x plus 1, 10 is one bracket, and what will remain? X plus 2, put it in another bracket. So now our p of x polynomial is factorized in three factors. First is x plus 1, second one is x plus 10, and third one is x plus 2. Okay, this polynomial is now factorized in the three factors. So in this way, whenever we cannot take anything as a common from this given polynomial, we have to use this trial and error method. First of all, we have to decide one of the factor. If we take one of the factor and by putting the value of x in this polynomial, if the remainder becomes 0, then that will become the one of the factor of this polynomial. And then we have to divide this given polynomial with that factor so that we can find out this quotient polynomial. And by factorizing this quotient polynomial, we get the another two factor. Okay, so this is all about the factorization of the polynomial. Okay, so this is all about this lecture. Thank you.